Now for our first speaker of this second part of Architecture Live. He's live from Melbourne in Australia. It's GWYLLIM Jahn. Now he's going to be sharing with us his vision of architecture for the future. Welcome GWYLLIM, and it's great to see you as a hologram, especially as you're in charge of a technology company called Fologram working on hybrid reality. So you're the right man to turn to and ask whether our program is also hybrid reality and whether digital society and communicating with each other via different digital solutions is our immediate future, the so-called mixed reality.
It could be. Standing here in Melbourne, I'm yet to see how I'll appear in Tallinn, but this is definitely a step towards mixed reality. So Fologram is a software startup building software for mixed reality construction. We also do some research and development, which is exploring how we can extend craftsmanship using holographic guides, as well as improve how we collaborate with different experts on site and work with materials in new and exciting ways. Now, our interest in extending craftsmanship, it's really trying to create a kind of counterpoint to the prevailing trends within industry. So companies like Katera are employing robotic automation to really try to improve the efficiency of making fairly standardized buildings. So this means making a fairly simple kit of parts over and over and over again in order to minimize the cost of that kit of parts. And if companies like Katera become kind of successful at replicating this business model, then the role of the architect is going to be that of a specifier. So they'll be selecting finishes or modules from this library of parts that might not even be defined by an architect. So what we're interested in doing is trying to create kind of an alternative to this. We're interested in using mixed reality to extend what we can design, like extend the scope of possible designs by extending how and what we build. So we work a lot with craftspeople, maybe who are not necessarily digitally literate, and we're trying to upskill those people by providing them access to the precision of holographic models. And this is creating all sorts of really exciting opportunities for making. So as you can see here on the screen, this is a sculptor from Yackandandah in Victoria who's using holographic models to form the incredibly complex stainless steel tubes of these beautiful winged structures that form pieces of public art. Or this is Jeff Farquhar Still, another art fabricator, who's exploring how to kind of build these wildly complex digital models using holographic guides with his team of artists and fabricators up in Canberra. So when we first started working with the HoloLens almost 4 years ago now, one of the first things that we tried doing was really just using the design model that we develop as architects and designers as the only instruction set for fabricating those design models. So for instance, we might have a three-dimensional sketch of a chair that we were trying to build, and these sketches, when you model them digitally, they can be wildly complex pieces of geometry, especially if you're sort of fairly early in the design process and you're not worried too much about how bits of geometry might intersect or whether every part in the design is different. You're just trying to capture the design intent of the form that you're making. So with the case of this chair, every single piece is different, everything intersects. It's just a very, very quick digital model. It takes about 20 minutes or so to produce, and it captures really just an idea of how this chair might look. It looks like a tangled root system or something like that. Now, when we make this chair, you use that digital model as an approximate holographic guide. So you're not asking the fabricator to produce this chair exactly, you're asking them to match the design intent as faithfully as they can. So on the HoloLens, they can see what the end product of the design is supposed to be, and then they can use their intuition and skill as makers to capture that as precisely as they can, whilst still trying to optimize for an efficient fabrication process. So for instance, where they see in the design model two pieces of steel which are intersecting and overlapping, they know they can't physically make that with physical material, and so they just make minor adjustments to that physical structure to closely match the design intent while still solving for that fabrication constraint. So what this does is it allows us to make these wildly complex models very quickly, but somewhat approximately. And normally with traditional or even digital processes of fabrication, you have a kind of all or nothing scenario. So you can either make something exactly or not at all. And that exactness comes with cost in terms of time, expertise, machinery, etc. Now, this mixed reality approach to construction is also going to have an impact on even more conventional building, and it'll have an impact for a couple of reasons, we think. The first one is that viewing models on the HoloLens and mixed reality just makes that digital content very accessible to anyone on site, regardless of their digital literacy. So you don't need to be a guy that knows Revit or BIM models or knows how to open various PDF viewers or what have you. You just put on the headset, you can see the content, and away you go, you understand it. The second thing is that these mixed reality environments, they can be co-inhabited by multiple people at once. So you can have an apprentice and a project manager looking at the same thing at the same time, and it's a very unambiguous way of communicating spatial information. And then the third thing is this information becomes precisely located on site. So you can use it to extend existing processes of making. You don't necessarily need to just change or replace how people work. And this is, we think, really, really important if you're going to have an impact on the construction industry. Nobody wants to chuck out their existing skill set and go learn something new. Everybody wants to be a kind of a master craftsman. They want to continue learning, continue improving how they currently work. So here's a project that shows this idea by Colin and his team at Albrick in Tasmania. It's just a simple feature wall, and Colin's going to tell you a bit more about this project.
There isn't a single brick on there that lines up to anything. Every brick is different. This would take you like 2 weeks.
Yeah.
Fine guy, and a lot of that would have to be, made up. Do you know what I mean? You're not going to get it exactly like this would be.
So how Colin was able to build this wall is with a very simple holographic user interface. So you click on a button and it changes the course of bricks that you see on the HoloLens. Then you just place a physical brick where you see a digital brick.
So that's all the bricks, right? Yep. So see how you are here. That one's good. Yep. This one here shows it's got to come round. So just treat that like you do your string line all the way around. Mm-hmm. So hit that back.
So this let Colin and his team invent new ways of bricklaying. So once they were able to see where the bricks were supposed to be on the headset, they could figure out new workflows to efficiently construct this brick wall. And one of the things they invented was they would have one guy wearing the headset going through and approximately placing the bricks, just really, really quickly, bam, bam, bam. And then they'd have another guy wearing a headset following along and very precisely adjusting the position of each brick to exactly match that holographic model. So they worked out that that was quicker than just one person doing it precisely to begin with, and the result is like a very precise project.
I once seen a program on John Lennon, and he reckons every song that he made, he used to get scared that, fuck, I'm going to stop now because I'll never make anything better than that, That's how I'm thinking, fuck, it's time to stop. I'm nervous that I can't make nothing better.
So after doing that small feature wall, Colin asked us if he could use this technology on a much larger scale project. In this case, it was the Royal Hobart Hospital in Hobart in Tasmania. So the project then required doing these benches, which are up to 20 metres long, out of a whole lot of different cut bricks, on a very, very messy construction site with a much larger team of bricklayers. And the challenge that Colin was facing with doing this project traditionally was going to be that he would have to have his one most skilled guy on site chalking out exactly where each one of these brick walls would go, and then going along tediously placing each one of these cut bricks one at a time from one side of the wall to the other in order to maintain like a nice consistent bond between the bricks and match these kind of smooth flowing curves of the structure. Now, what the mixed reality model enabled them to do was instead start construction from anywhere in the wall and work in parallel. So they could have several guys all looking at the same model with the same collection of cut bricks, placing them wherever they saw them in the HoloLens, And it meant that they could scale up their fabrication process. So rather than having to build this structure linearly from the start of the wall to the end by one guy working gradually through this sort of process, they could do the same job with 4 guys, which meant doing it 4 times as fast without necessarily taking on any more construction risk. It didn't really matter whether or not those guys knew exactly what the overall form of the wall needed to be, because they could see exactly where each individual brick needed to be placed. So it minimized any kind of construction risk in building it in parallel while maximizing or reducing the time that it takes to build these structures. So this makes the brickies really happy for a couple of reasons. First of all, mixed reality technology is extending how they currently work. It's not replacing the way that they lay bricks with some new automated roboticized system, for instance. It's just meaning that they have more certainty when they take on a complex job, and they don't need to take on more risk to do these sort of more complex, ambitious projects. And actually, Colin has come back to us asking for more ambitious architectural projects to use this technology on, because his team now has the capability to deliver them. So the technology is upskilling the industry, and the technology change is making it more attractive to the next generation of apprentices. So Colin is hopeful that people are going to want to move into this trade because they're seeing that actually the trade is evolving and taking on these kind of new tools and techniques. It's making it more attractive. The other thing that I guess is exciting for the brickies is, of course, the technology is enabling them to build more efficiently. So it's reducing the kind of the cost and the time of these complex projects, and that, of course, is incentivizing them to take it on board with more projects in the future. Now, the other thing that we're interested in is exploring how mixed reality construction is able to affect how and what we design. So if we incrementally change our capabilities in terms of making, does that also change the types of things that we draw or conceive of? And with the 2019 Tallinn Architecture Biennale installation competition, we proposed a system of building which would combine the analog traditional craft of steam bending timber with the precision of very digital holographic guides in order to fabricate kind of arbitrarily complex curving timber strips that would make up the form of the pavilion. So it's kind of a simple idea in a way. We would just have a holographic template showing us how to lay out adaptable formwork. That adaptable formwork would make steam bending timber relatively cheap, and so we thought we could really go wild with the design. So this was the submission for the stage 2 of that competition, and this was published on ArcDaily. And when it was published, there was a whole lot of comments on the project from I presume, architectural experts in the public who opinionated that this just couldn't be built. This was paper architecture. This didn't look in any way rationalized for the constraints of construction, and therefore, if this was going to be the awarded submission, whatever would be built would probably look very, very different, and that was disappointing. The comments were quite negative. But on the other hand, we felt the same way. We were unsure about how this would be built. We had an idea about how to use mixed reality for constructing this project, but we'd never really steam bent anything from timber before, and so there was still this huge amount of uncertainty regarding whether or not this idea would actually work. So what you see here is after several months of prototyping with experts all around the world, actually, we managed to develop an approach to steam bending timber where it was very, very simple. You would put an entire length of timber up to 12 meters long in a large plastic bag, and you would steam that timber for half an hour or so until it got very, very hot. And then a team of fabricators would just bend that strip of timber while it was in the bag until the physical piece of timber perfectly overlapped with a holographic representation of the shape that timber needed to be in the pavilion. So what you see on the screen is the red geometry is the shape of the timber strip coming directly from the design model, and then you can maybe make out the kind of the timber in the bag, which hopefully overlaps that red geometry, and when it does, you know it's right. So these are a couple of other clips of showing how we used these kind of mixed reality techniques in the fabrication space to build the pavilion. Here you can see the team of fabricators who are trying to line up, it's almost like a ballet dance really, the piece of timber with the green digital geometry describing the part. We added holographic guides to analog tools as well to enable us to build quite complex steel components in the structure without needing to spend lots of money on automation, robots, laser cutting, anything like that. We just make everything by hand. And then we had a holographic model on site showing us exactly where each one of these parts needed to go to correctly form the structure. And this was really important because the language of this pavilion is really like a big bowl of spaghetti. Everything is very, very flexible. And so when you assemble these parts on site, it's almost impossible to know where they go just from the shape of the parts themselves, because the parts just want to bend out of shape constantly. And so it was essential to have this holographic reference showing us the form that these timber strips and steel components needed to be in order to actually match our design intent of the model and, capture the sort of the intent of the project that we submitted during the competition stage. So the language of the pavilion is really trying to capture or in some way build upon the processes of how it was made. So these timber strips, they need to twist and curve in order to form these three-dimensional curves in the structure. And this creates this sort of interesting interplay where in some parts of the timber structure you can see through the strips, in other parts the strips start to overlap and form surface. And the combination of these strips can do very, very interesting things structurally as well. So they might bundle together to form columns which hold the structure up, or they might kind of cantilever out from the edge of the structure to create a little bit of shelter. And then there's these sort of wild formal moves where we're just twisting a wall into a column for fun and creating this kind of wave that you can get barreled in as you walk through it. We think that this structure, it's not really trying to be a shelter as such. It's not a structure which is solving any key function other than just being an object of delight in the city. So it's intended to be something that is playful. It's supposed to be a space which is explored. It's supposed to, in some way, start to frame views of both the new part of the city, which you can see over here on the left of the video, and also the old town, which is directly in front of this structure. And we're trying to, again, capture these sorts of, almost romantic idea of how these materials can be used in very, very traditional ways. Steam bending is a technology that's been around for a very long time, but in combination with quite new approaches to designing and making. So in this case, the way that this design was modelled was using very contemporary techniques. And that, I think, is kind of interesting. So rather than just using robotic processes of automation and construction to standardize how things are made, instead we're trying to take traditional analog ways of making and extend those with digital techniques to expand the scope of what we can make and what we can design. Thank you.